Hello, everybody. Let me introduce you Luciana, she's 5, and Kiana, she's 3. They are my beautiful daughters. They are right now, Luciana is in the why and how question mode. So she asked me at least 5 questions for one thing. So I gave her a toy, she will start asking me why this, and why this. So we designed these kind of boards, puzzle boards, for her to play around. And she started me asking questions. So how this? And I got to the point of the processor. So I say, okay, how should I answer this question, right? So you gave me an idea of, okay, she's interested. She might be interested later. No, now, of course, she's not gonna be easy for her to go and read RTL code or even schematic circuits. But maybe in the future, she will be able to tear it down. So this is a development platform for next generation. We call it YoPuzzle. It's based on a RISC-V based microcontroller, 32-bit. So where we are? So we are from Colombia. Colombia, South America. Colombia is the northest country in South America. We are located in a city called Bucaramanga in the Andes. We are famous from Colombia for sporting singers, but we also famous for exporting raw white silicon. It's not for making chips. It's not what you are imagining for, but for building houses. So let's have a look about the open source hardware market. Yeah, it's open source, right? So based on a claim from Raspberry Pi Foundation, they have sold by September 2016 10 million boards. I'm sorry for the Arduino guys that are here, but this is an estimation. We didn't find a number, so we did estimate it. We found out that it's about 4.4 million Arduino boards sold by July 2016. And there are tons of reports from the industry saying, hey, this market will be worth about 1 billion within the next 4 years. So, by the way, one of my favorite applications from Arduino is this one. This guy built an office chair, and this board, it twists every tiny parts. So it's super cool. You gotta check it out. So just imagine, getting those tweets. We also run a popular contest. So this is, this Google Trends thing. So we say, okay, let's check it out how popular is Raspberry Pi. So we found out that, yeah, within 3 years window, Raspberry Pi, there are sometimes that it's being more popular than Lady Gaga. We did the same thing for Arduino. And Arduino actually is becoming popular most of the time. This is within 1 year. You might see that even Arduino is popular in Colombia. Yeah, in average. So you see the map. We also try to be updated, right? So we did the Arduino against, who's that guy, right? The red one, Donald Trump. Okay, so Raspberry Pi and Arduino boards are based on commercial closed source silicon. We love Arduino and we love Raspberry Pi. I mean, I guess most of their effort, I do believe that we are here just because they have done it. So we developed a 32, we tip it out, we test it, and it's working. Actually, we are going to try to demo it. As we said, we prayed enough last night for the demo guide. Let's see. So what is this 32 RISC-V based microcontroller? So this, all what you see there, except for the standard cells, even there are some cells that we also handcrafted. What you see there is all done by our team. So there is no IP providers there. Maybe the pads. I'm not talking even about the GPO, just the pads. So we have done the AC4 light bus. We had developed the AP bus. We had done VIP for those buses. We had developed ADC converters. We had developed DAC converters. We are going to talk about that in the next presentation. We put this chip in a chip on board. You can see there, those wire bonds are kind of crappy wire bonds. But if you can look closely, there are down bonds. Those down bonds, those are the ones that go to the ground, and they are the ones going to the power supply rails. So we are also trying to get high-speed IOs. So in order to get those high-speed IOs, you need to do a lot of work on power integrity. First of all, you need low inductance, so that's why we want to have control of that. So there is the board that we are using. So here is the performance that we got for this chip. So the ISA is our RB32IM with some interruptions. The architecture is a single issue in order three-state pipeline. We tape it out in 130 nanometers TSMC general purpose. The die area is about 2 by 2 millimeters. The microprocessor core, the core, is about 0.12 millimeters square. So we measure, we clock it, actually even from kilohertz, but here in this table to the right, you are seeing the core frequency, and we measure both supplies, the 1.2 and the 2.5 volts. Just remember that 0.5 volts is the I/O supply. We measure the current by clocking it, and we put running an application there that is about 3 while loops. We all executed from SRAM, and all peripherals called disabled. So we try to be close to whatever is in the data sheets of the M0 plus microcontrollers out there. We got about 165 microwatts per megahertz when we are clocking it to 100 megahertz. Yep. So we, by the way, we were able to clock it up to 200 megahertz. So yeah, here is a performance comparison. You can see I mean, we are not the lowest power in the market. I mean, we are not in the market, but just compare it to the market. But we are able to run it kind of up to speed. I would say that it's because of the technology, but you saw that the sci-fi guys are claiming 300 megahertz. We also have an ICDC there working properly, 10 bits, 10 mega samples per second, which is quite a speed for a lot of application. So this is trying to, we aim the SAMD21. So we were trying to compare it to the SAMD21, which is the microcontroller that is in the Arduino Zero boards. Here is the development board. We might see it later in the demo. So we are exercising all the GPIOs, the ADC converters, the converters. Okay. Okay, now let's talk about this idea that I talked to you at the beginning about YoPuzzle. But those who didn't pass Spanish one, yo means I. They're still saying I puzzle, like YoPuzzle. So so these are the boards. So first of all, you will see the Arduino guy. I mean, Arduino is aiming a lot of age range people, right? You will see schoolers, like high schoolers, students doing a lot of projects, like the one in the picture. And they're doing books about that, about Arduino 14s. But you will not see any kids playing with Arduino. I mean, it's hard. It's kind of, you need maybe to be in high school or middle school to do that. By the way, you can do this now. You can do kind of this calculation. You can ask your neighbors. And from 5 families, you will see that about 3 of them have an Arduino board, which is quite a big market, right? So what about the 1 to 10 years old demographics? So what about Maggie, right? Maggie's supposed to be the genius at home. So there are quite plenty of studies that say that you have to nurture creativity and inspiration in this during this age. So this is an example. You can ask now a kid, a 4-year-old kid, where does the milk come from? He's gonna say right away from Walmart, right? That's kind of a pain. More painful there is that if you ask the parent, your kid knows technology. Say yes, he can go and drag the fingers around the tablet, and so she knows a lot of technology, right? So that's also kind of painful. So technology should empower children, but it's doing the opposite. So here is the proposal. We are putting this board. We are putting this microcontroller in this board. So I don't know if you guys remember the logo programming from MIT, where this robot turtle was supposed to teach programming. So we are kind of doing the same. Just imagine this. There are 4. It's a set of 4 pieces for like 3 years old girls or kids. And once she's changing the places of the pieces, she will start seeing different patterns. Here is an example. Here, this is a touch controller on the board, so you're just touching it and just going around. It's seeing that the LED matrix, there's another piece, is going in that direction. So it just starts turning the puzzle and putting it there. It's going to start seeing different things, different patterns. So that's kind of idea. We did an exercise. We went through all the schools in Bucaramanga, in our city, and give it away and give the boards there just for them to play without any instructions. They just start pushing it out. They start seeing patterns and they start playing around and having fun without any instruction. So that's the good thing about this toy. So you don't have to give instructions. The kids are exploring by themselves. So right now we are in crowd supply. We are aiming to produce 70K chips. It's a low volume, but you need money for the mass set, and even for the wafer and testing. So wafer testing plus packaging testing. So we please support us. So yeah, here is some timeline. We are aiming to have these boards ready for the second quarter, 2018, with those chips. By the way, you will see that also we are taping our chip with a convolution neural network as an accelerator in one of the microcontrollers. You will see, wow, a 32-bit microcontroller was saying, well, we might talk that later. Okay, so again, we do believe that empowering new generations is the way to bridge the gap. So as I said, let's check if we have prayed enough to the demo God. So we are now doing the demo. So back there, we have the board. I guess we are gonna start sharing the screen. Let's see. Okay, okay, there you go. So on your right-hand side screen, you will see, so this is a Google, let me see, this is Chrome. This is just Chrome. Then you have on the right side, you just have the boards just showing kind of the demo that you can do. So you can do the programming in the middle. This is the RISC-V base. Just go up, Christian. He's helping me out. So you see the code in RISC-V. You can also CNC and just modify it there right away. Just CNC, just click on zip, the C code. So you also will be able to see, go back to the RISC-V. Okay, then in the left part of the left column, you will see some kind of a starting point, maybe for kids. You can change the number of frames. So here we have different frames, maybe increase it, then the code is changing. You can even change the timing. So what you see here in the red points are the LEDs that we are gonna start turning on and off. Actually, that is the board, cool. So right now, you see that pattern going on there, regular pattern. We'll see, there is a cable, that cable that is there in the down part, is just a SPI to USB cable. So we can have this board in China right now, we might have it, and then working from here, just doing development from here and programming it from here. So we are gonna try to do it through Chrome. So then you can just go ahead and maybe turn on some LEDs and turn it off, Christian. Just click on the notes. Okay, he's right now. So he asked for a ticket because, I mean, we are doing a demo. Maybe somebody's gonna get in that one. So he's programming now. So then it stops there because it's programming, and now it's going to start doing the pattern. Okay. So now it's programming. So he's resetting the chip. Just let's see what the pattern is. Okay, so then in the upper left hand side, you will be able to share his programming right now, and you can even compile, see the hexadecimal code, and then run it. Right now, it's there running the pattern, as you see. You can even change the pattern here just by clicking, Christian. Just click on the pattern just to show on the pattern. Just click their buttons. Yeah, so it's kind of easy. So we are also, as I say, we are thinking also, okay, RISC-V should be also, I mean, all these, like I said at the beginning, how and why questions of my girls, should start empowering that. So I'm trying to empower that is just try to give them as accessible tools for maybe 7, this is maybe for 6, 7, 8 years old. Okay, that's it. Any questions? No questions? Come on, Rick, you gotta ask a question then. That's the way it works in conference, in academic conferences.
Where's the debug port?
Wow, you're killing me, right? You know that you're killing. That's definitely a good question. We don't have a debug mode. You kill me. But we are in the next step. We are putting a debug mode. Also, so Guy might be here. Gajinder, he's helping us out. So yep, we are gonna put a debug there.
Yeah, I was kidding.
You were kidding. Okay.